Section 2.1. I'm sorry, 2.1, 1.2. I skipped the whole chapter there on you. Section 1.2, graphing linear equations. Does anybody know what a linear equation is? When you graph it, you happen to get a line. That's true. But if I were to write an equation down on my piece of paper here, just by looking at that equation, you should immediately be able to tell me if its graph is going to be a line or not. So, if it's in the form y equals mx plus b, then it's definitely a line. That's one of the important forms. One important linear equation. This is the one most people know. Y equals mx plus b. So if your equation is written that way, if you have y equals some number, and then an x, and then a plus b, you're guaranteed that that one is linear. That's true. Okay? What makes that one linear, though? Why is that one linear? All right, I'm going to write a bunch of equations on my piece of paper here, and you're going to tell me if they're linear or not. So I'm going to write y equals 3x minus 5. Y equals 4x squared plus 2x minus 7. 3x plus 5y equals 9. Some more equations. How about y equals 6 square root of x? Y equals 7. X equals 2. And then one more, maybe 2 more. Y equals 1/2 x minus 3. Y equals 4 over x. All right, so there's a whole bunch of different equations. Some of those equations are linear and some of them are not. And by the end of today, you should immediately be able to look at an equation and say, yes, it's linear, or no, it's not. All right, so number one, y equals 3x minus 5. Linear or not linear? Yes, linear. Why is that one linear? It has 2 variables. Yep. We've got, this one fits right into this y, it fits right into that y equals mx plus b, doesn't it? Y equals 3x. Well, it's supposed to be plus a number, but is it okay to write minus a number? Yeah, because minus 5 is really the same as plus a negative 5. So that's okay. So this first one is linear. It fits right into that y equals mx plus b form. Second one, y equals 4x squared plus 2x minus 7. Is that one linear? No, why not? Because it happens to be a parabola, that's true. Whatever a parabola is, we'll study those later in the semester. But how do you, well, okay, so you know that when you graph that, you get a parabola. What else tells you that that one is not linear? Go ahead.
It doesn't fit into the equation. It has an x squared.
It has an x squared. That's the big thing. So if you see an equation, and that equation has a power, if it has an x squared or an x cubed or an x to the 4th, or any power like that, you know right away that that's not linear. So you're correct, that one is not linear. That one happens to be something called quadratic, and if you graph it, you get a parabola. So this one is not linear. Number 3, 3x plus 5y equals 9. Linear or not linear? Yes, linear. Why is that one linear? You could rearrange it, couldn't you? Could you take that equation and get y all by itself? Yes, so that one is linear. When you get y all by itself, are you going to have any powers or anything like that? No, and that's really the key to this one. I look at my variable x. X has a power, but the power, we don't write it. The power is really a 1. The y also has a power. The power is 1. That's what tells you it's linear. It's linear if all the powers are simply the number 1. So this one is linear. Number 4, y equals 6 square root of x. Linear or not linear? Not linear. What's wrong with that one?
Square root.
It's got a square root. If you see square roots on your variables, that's not linear. Y equals 7. Linear or not linear?
Linear.
Linear. How come?
It's got the x value is 0x. You just don't write it as that.
Okay, so what you're saying is I could write this as 0x plus 7, and I can make it look like it's in y equals mx plus b form. I agree, that's linear. Or the other answer would be, I looked at all my variables, the only variable I see is a y. What's the power on that variable? 1. So this one is linear. That one turns out to be a special kind of line. We'll talk about that in a few minutes here. X equals 2, linear or not linear? Look at all your variables. How many variables are there? Just one. What's the power on that one variable? 1. So is that linear or not linear? That one's linear. All the variables have power 1. That one's linear. Again, another special kind of line. We'll look at that in a few minutes. Y equals 1/2 x minus 3. Am I allowed to have fractions? Sort of. That one, y equals 1/2 x minus 3, is linear, while the next one, y equals 4 over x, is not. So what's the difference between those two? You can have fractions, but the fractions have to be something special. So what's wrong with the last one? Why is that one not linear?
Division.
Well, this one has division too, 1 divided by 2. Because what's in the denominator? A variable. That's correct. Okay? This fraction is okay, this 1/2, because this fraction only involves numbers. You can have fractions as long as the fractions are only numbers. This one is not acceptable because the x is in the bottom. If you have a fraction and you have a variable in the bottom, that makes it not linear. And there's a reason for that, and we'll talk about that way down in the line here. But you could rewrite this. This one actually could be written with a power, and the power would be a -1. So we haven't talked about that yet, but we will. General rule for now is if you have a fraction and you have a letter in the bottom, it's not linear. So this one is not linear, while this one is linear. This one's okay. It has a fraction, but the fraction only has numbers down on the bottom. Questions on any of that? All right, now how do we graph a linear equation? Let's pick a couple that were linear here. Let's see, y equals 3x minus 5. We're going to graph that. There are many different ways to graph linear equations, and I'm sure some of you have had algebra in the past and you know some tricks about graphing linear equations. But pretty much what we're going to do for now, what we're going to do in this section, is we're going to build a t-chart. X and Y, like so. And we're going to pick, let's say 5 of our favorite numbers for X, and we're just simply going to plug them in. So somebody tell me one of your favorite numbers. What numbers do you like? 42. All right, 42 is an excellent number, but in general, I would recommend keeping your number small. 0 is always my favorite number to plug in. That's always the first one I would use. So I would use 0. And what do you get for y when you plug in 0? What's 3 times 0? 0 minus 5. -5. All right, so I always plug in the number 0. That's my favorite number to plug in. And then generally, I pick 2 positive numbers and I pick 2 negative numbers. So give me 2 positive numbers. 1 and 2. 1 and 3. 1 and 2. I'm going to plug in 42 just for fun. I'm not going to ignore it. There's nothing wrong with the number 42. We will just see that the number 42 would make things kind of difficult to graph, I think. So we'll see what happens. All right, so what happens when I plug in 1? What do you get when you plug in 1? -2, because you get 3 minus 5, that's -2. And when you plug in 2, 3 times 2 is 6, minus 5 is 1. How about when you plug in 42? 42 times 3 is 126, I think. 126 minus 5 is 121. All right. Again, nothing wrong with that. Difficult to graph, depending on how you do your scaling. All right, so I used 0. I picked a couple of my favorite positive numbers. Now I want to pick a couple of my favorite negative numbers. What are my two favorite negative numbers? -1 and -2. All right, -1 and -2. I plug in -1. I get, what do I get? -3 minus 5 is -8. And I plug in -2. I get -11, I think. Okay, then we come over here and we build our axes. So you draw your x-axis and you put some scaling on it. And you draw your y-axis and you put some scaling on it. In this case, I scaled my axis probably the most standard way. Every little tick mark stands for 1. Does every little tick mark have to stand for 1? No, it doesn't have to. Why did I choose to pick every little tick mark to be 1? What's that? Easier to go by. And also, I was looking at my numbers here, and my numbers, except for this one, of course, 42, 121, my numbers are all fairly small. If my numbers were kind of big, then I might use a different scaling. All right, so I think I'm going to need to extend my y-axis a little bit here. All right, so I marked my points. I marked the point 0, -5. Where's 0, -5? That's right. The 0 tells me start at the origin, don't move left or right at all. And then the -5 tells me go 5 down. So that point is right there, 0, -5. 1, -2. Where's 1, -2? So I start here, I go 1 over and 2 down. 2, 1. I go back to my origin, 2 over, 1 up. And at this point, so far, I'm pretty sure I have not made a mistake. What would lead me to believe I've made a mistake? Yeah, right now if I connect the dots, it looks like I'm going to have a straight line. If this dot, if I had put this dot right here, maybe if I'd made a mistake, I'd be pretty sure I was wrong because my 3 dots don't fall in this nice straight line. We know our dots should fall in a nice straight line. So that's kind of a built-in check on these. Okay, so that point is wrong. I was just putting that point in there for emphasis. All right, so what's wrong or what's difficult about 42, 121? My scaling is poor. 42 is way over to the right off my axis, and 121 is way up high off my axis. Nothing really wrong with that point, just hard to deal with the scaling. So I'm not going to try to draw that one. -1, -8 is right there. And finally, -2, -11 would be right about there. And if I've done it right, my dots should fall into a nice straight line. Do my dots fall into a nice straight line? Well, kind of. Not perfect. Why not? My graph isn't perfect. Are my little tick marks all the same distance apart? No, because I just kind of eyeballed it. But they should be more or less in a line. Of course, if I were using graph paper and I had a more accurate graph, I would be more convinced it was a line. Should be a line. We connect the dots here. There we go. There's our graph. Questions on that? All right, now this line has 2 really, really important points. Can anybody tell me what the 2 really, really important points are on this line? 0, -5 is one of them, and that's called the y-intercept. And what's the other really, really important point? The x-intercept, but do we know what the x-intercept is? No, we can see it. It's right about here. Here's our x-intercept. What I want to do is I want to figure out that x-intercept. I want to know what that is. The y-intercept was easy to figure out, wasn't it? The y-intercept, we figured out just in building our table. It just jumped right out at us. Happened to hit it. What about the x-intercept? How am I going to find that x-intercept? Okay, plug in what numbers? 0 for y. Why should I plug in 0 for y? That will let me figure out what x is. What is this point right here? Well, I don't know what this point is. I know the x number is something positive, but what's the y number have to be? It has to be 0. Why does the y number have to be 0? Because you're right on the axis, aren't you? On that axis, y is always the number 0. So I don't know what this point is, but I know it looks something like this. I know it's something comma 0. So in order to find the x-intercept, I plug in 0 for the y number. So I go to my equation, y equals 3x minus 5, and I plug in 0 for y. So 0 equals 3x minus 5, and then I need to get the x all by itself. And I'm hoping at this point you all know how to get the x all by itself for this kind of equation. What would you do? Add 5 to both sides. 5 equals 3x. And then divide by 3, so x is 5/3. So our x-intercept is the point 5/3 comma 0. All right, so once again, how do you find the x-intercept? To find the x-intercept, what do? Plug 0 in for y, and conversely, to find the y-intercept, how did we find the y-intercept? We got it right here. What did we plug in? 0 for x. All right, let's try another problem. Y equals negative 1/2 x plus 3. Again, I'm going to build myself a little table. And again, I'm going to pick my 5 favorite numbers. I'm going to pick 0, and I'm going to pick 2 positive numbers, and I'm going to pick 2 negative numbers. All right, so I plug in 0 for x. If I plug in 0 for x, what do you get? 3, because negative 1/2 times 0 is 0. 0 plus 3 is 3. What are your 2 favorite positive numbers? 1 and 2. I disagree this time. I like 2 a lot, but I don't like 1. And here's what I don't like about 1. I'm going to plug 1 in. I'll show you what happens. What happens when I plug 1 in? I have negative 1/2 times 1 plus 3. What's negative 1/2 times 1? Negative 1/2. What's negative 1/2 plus 3? 2.5. Or you could write it as 5/2, and you end up with a fraction. Personally, I don't like it very much when I end up with fractions and I have to graph. How come I don't like fractions very much? They're harder to graph. When I graph, I want things to come right on the tick marks. So again, while there is nothing wrong with this, I'm personally not a fan of it because I deal with fractions. I don't like fractions very much. So in my opinion, 1 for this problem is not a great number to plug in. Because when you plug in 1, you end up with a fraction. So what is a good number to plug in? 2 and 4 would be very good numbers to plug in. Why 2 and 4? Because they're even. And what's going to happen when I take an even number and divide it by this 2 that shows up here? I get a number. I don't get a fraction, do I? Okay? So if this number in front here is a fraction, then you want to pick your numbers a little bit more cleverly, perhaps. You don't just want to use 1 and 2. It's a good idea to pick some numbers to try to make that fraction go away. So if this fraction here, if this fraction were 2/5 maybe, what would be good numbers to pick? 5 and 10, how come? They're multiples of 5, they will make the fractions disappear. So that's kind of what you want to do. All right, so I would use 2 and 4. What's negative 1/2 times 2? Negative 1 plus 3 is 2. And then I plug in 4. 4 times negative 1/2? Negative 2 plus 1? I'm sorry, negative 2 plus 3. I kind of gave away the answer. Negative 2 plus 3 is 1. Okay, so my favorite numbers this time for positive were 2 and 4. How about my favorite negative numbers? Same idea, negative 2, negative 4, so that the fractions go away, we end up with real nice numbers. Is it okay to mess with the fractions? If you like fractions, is it okay to use 1 and 2 and negative 1 and negative 2? Sure it is. Nothing wrong with it. It's my personal opinion that I don't like the fractions, so I avoid them. All right, I plug in negative 2. Negative 1/2 times negative 2.
Negative 1. A positive 1.
Positive 1. Because when I multiply two negatives, a negative times a negative gives me a positive, and then 1/2 times 2 gives me a 1. So that's 1 plus 3, that's 4. And negative 4 times negative 1/2? Positive 2. 2 plus 3 is 5. So there's all my points. All right. Draw my graph here. Once again, it's critical that you give me a scaling. If you don't give me a scaling, if you don't label your little tick marks here in some way or the other, I will take points off. I guarantee. I'll have to label your graph. All right, so 0, 3 is right here. 2, 2 is there. 4, 1 is right about there. Negative 2, 4. And negative 4, 5. And once again, I look at all my little dots, and I'm pretty sure I did it right. Why am I pretty sure I did it right? Because they all line up. If one of the dots was out of the line, then what would that tell me? I made a mistake somewhere, and I'd have to go back and check my work and fix it. But those all line up nice and neatly. So I draw my line. Once again, my two very important points. Right there is my y-intercept. What's my y-intercept? 0, 3. And over here is my x-intercept. What's my x-intercept? I don't know yet, but I can figure it out, can't I? I plug in 0 for y. So I'm going to have 0 equals negative 1/2 x plus 3. How would you solve that equation? Minus 3 on both sides. Minus 3 equals minus 1/2 x. And then how do you get rid of that minus 1/2 in front of that x? Multiply by the reciprocal. I love that answer. And what's the reciprocal of negative 1/2? Negative 2. So I'm going to multiply both sides by negative 2. Negative 2 times negative 3 is 6. And over there I would just get x. The negative 1/2 and the negative 2 cancel each other out. So my x-intercept is the point 6, 0. Questions on that? Two x minus 4y equals 8. How would you graph that one?
Changing the y-intercept 1.
Okay, that's the way most people would tell me to do it. Most people would tell me, take that equation and get y all by itself. And that absolutely works. Absolutely nothing wrong with that. It's not the way I would do it. I could take a 2 out of everything. That's true too. I could reduce and factor. Here's what I would do. I tend to be kind of lazy. I don't like to solve things if I don't have to. I'm going to build a little table still. Pick my very favorite number for x and I'm going to plug it in. What's my very favorite number for x? I'm going to plug 0 in for x. So what point am I finding? When you plug 0 in for x, that always gives you the y-intercept. Okay? So I plug 0 in for x. What's 2 times 0? 0. So really that piece is just going to go away. Can I solve that equation? Can I get y all by itself? Yeah. What do you get when you get y all by itself? Y equals -2. Then I'm going to go ahead and I'm going to find the x-intercept. How do I find the x-intercept? Plug in 0 for y. So I plug 0 in for y. That's kind of weird. You don't usually plug numbers in for y. You usually plug them in for x. But you can. There's nothing stopping you from doing that. I plug 0 in for y. That means that minus 4y piece is going to disappear. So x has to be 4. Is that easier or harder than getting y all by itself? I think it's easier. Is there more chance for a mistake or less chance for a mistake? I think getting y all by itself, I think you have more chance for making a mistake. That's my opinion. So what I would do now is I would just go ahead and draw my graph. To draw a line, really you need 2 points. That's the bare minimum. And that's what I have. All right, so I think what you're saying is there are some dangers in doing it this way. And I agree. Danger number 1. If I only draw 2 points, I'm guaranteed that those 2 points will always be in a straight line, won't they? So do I have any way of knowing if I made a mistake on one of those 2 points? No. I might have made a mistake and that might be screwed up. I have no way of knowing. I'm trusting that I did it well. So you got to be confident in yourself. And I think what you were getting at is, what if instead of a 2x here, what if this had been a 3x? And then I had to divide by that 3, I would have ended up with 8/3 for my x-intercept. And would I be happy with that? No, not really. So in that case, if the numbers didn't divide evenly and give me nice answers here, then probably I would go back and I would get y all by itself, and then I would plug some numbers in and make sure I have some nice numbers. So this method isn't perfect, I agree. But it's kind of a nice shortcut when the answers happen to come out nicely. Works real well. All right, now we got to talk about 2 special kind of lines. So we decided a little while ago that something that looked like that, y equals 4, we decided that was a line. We decided that was a line because we looked at all the variables and the only power was 1. What does that line look like? Vertical? Horizontal? It's one or the other. I'll concede that it's either vertical or horizontal. Which one is it? Horizontal. How come? But doesn't y go up and down?
Yeah, but the point is on the y-axis.
On the y-axis.
All right. You're right, it is horizontal. I'm going to build a little chart here and I'm going to make up some points. If I plug 0 in for x, what's y? 4. If I plug 42 in for x, what's y? 4. If I plug negative 36 in for x, what's y? 4. How come? Y is always the number 4. There's no x in the equation. It doesn't matter what number I use for x. Y is always the number 4. All right, so there's 3 points. Let's draw those. This this time, when I draw my x-axis, I think I'm going to scale it by tens. Why do I think it makes sense to scale my x-axis by tens? Because I picked larger numbers. I picked 42 and I picked negative 36 just to have fun. I got sick of picking 1 and 2, and 42 seemed to be a good number today, so I used it. How about my y-axis? Would I scale my y-axis by tens? No, probably by ones still would make sense because I only have to go as high as 4. So your scaling doesn't need to be the same on each axis. You can have different scaling. That's okay. All right, so I have the point 0, 4. That's right there. 42, 4. Well, I don't know exactly where that is, but I know 40 is here. 42 would be a little bit bigger. 42, 4 would be right around there. And the same with negative 36, 4. Negative 30 is there, so negative 36 would be right about there. And 4 is there. So what kind of line do we have when we connect the dots? Horizontal. We definitely get horizontal. So if I give you the equation y equals a number, y equals a number is going to be a line. What kind of line is it going to be? Horizontal. How about if I switch it? How about if I give you x equals a number? Then that's going to be a vertical line. Okay, let's just try one. How about x equals 3? Well, again, this one's kind of weird. I'm going to plug numbers in for y this time. I'm going to plug 0 in for y. If y is 0, what's the x number? 3. If y is 2, what's the x number? 3. If y is negative 3, what's the x number? 3. The x number is always 3. That's what the equation says. The x number is 3. Y can be any number you want it to be. And just drawing this quickly. Draw all these points. 1, 2, 3. 2, 3. 2, 3. So I have 3, 0. I have 3, 2. I have 3, negative 3. I get a vertical line. So those are special kinds of lines. If you have y equals a number, you will always get a horizontal line. If you have x equals a number, you will always get a vertical line. Questions about that? All right, the last thing I want to talk about, your calculator. This calculator can do a lot of interesting things. And one of the interesting things it can do is it can graph. It is a graphing calculator. I'll turn it on. How do you use this calculator to draw a graph? Let's say I wanted to graph, I don't know, what was one of those equations we had before? Y equals 2x minus 3, for example. How would I graph y equals 2x minus 3? I push the y equals button, which is this one up here. And it gives me a list of y1, y2, y3. I can graph a whole bunch of equations at the same time. And then I simply type in 2x. The easy way to get x is this button right here. X minus 3. And then how do I make it draw me a graph? I push the graph button, which is over here. And it draws the graph. Now, there's only one thing I'm a little worried about. What's the one thing I'm a little worried about? There's no labeling. There's no scaling on the axis. In this graph, what are those little tick marks? My guess would be that they're 1, but do I know for sure? Can't I check it? Absolutely, I can check it. How do I check it?
Press window.
Press window, which is this button right up here. If I press window, what this tells me is x min is negative 10, x max is 10, x scale is 1. So what that tells me is when I look at this graph, all the way over here to the left, that's negative 10. All the way over here to the right is 10. And the x scale was 1, which tells me each tick mark is indeed 1. And if I go back to the window, the y is set up the same way. Negative 10 to 10 and 1. But that's something you need to be careful about when you use your calculator. For example, if I were to go back here, let's say I change this to 2x minus 30, and I push the graph button, it looks like nothing happened. Why does it look like nothing happened? because my scale is no good. This graph, I had 2x minus 30, so what's the y-intercept? When you plug in 0 for x, what do you get? Negative 30. It's way, way down below. So what I would have to do for this one is I would have to change my window. I need to make it go down at least as low as negative 30, and I probably want to even go lower than that. So negative 40. And how about my y max? How high do I want it to go? 40, 45. I like to keep it nice and symmetric, so I would go 40. But now, if I'm going all the way down to negative 40 and all the way up to 40, do I want my calculator to try to put one little tick mark on every little spot? No. So what would be reasonable for tick marks now? 10 would be reasonable. So it would go 10, 20, 30, 40. It would draw 4 of them. That would be okay. 5 would be pretty good. Okay. Here's what I would use. This number started as 10, and I changed it to 40. That's 4 times bigger. So I would make my x scale be 4 times bigger. So I would use 4. That's my opinion. The other answers you gave me are fine, and it would draw the graph. But what you need to be careful of now on this graph, this first tick mark here, this is not negative 1, that's negative 4. So this is negative 4, negative 8, negative 12, negative 16, so on and so forth. But on the x-axis, this still goes 1, 2, 3, 4, 5. So you need to be careful when you're using your calculator about scaling, because you can look at a graph and it can look perfectly fine, but your scaling might be weird. Questions on that? Each problem is different, so usually you have to set it up based on what the numbers are in the problem. I would say for the most part, you're going to want that window that we started with, that had negative 10 to 10 left to right and negative 10 to 10 top and bottom. Okay, so there is a very easy way to always get back to that window. So let's say I was doing the next problem, and the next problem was 1/2 x minus 2. And I wanted to get back to that window very quickly, that negative 10 to 10, negative 10 to 10. There's a quick, easy way to do it. Anybody know? You hit the zoom button, and you go to number 6, which is zoom standard. So that's a good way to... I usually, when I'm graphing something, I usually don't hit the graph button. I usually hit zoom and then number 6. And then I know what my window is. I know what I'm starting with. I know I'm starting negative 10 to 10 and negative 10 to 10. Okay? Sometimes I hit zoom 6 and nothing shows up. And that tells me, okay, my window's bad, and then I got to do a little more work and figure out what my window should be. But this at least gives me a reference, gives me a starting point. All right, here's one more other really cool thing about this calculator. Do you remember on these problems back here where we were building these tables? So like this problem here, we had to build this table and we had all the fractions. The calculator will do that for us. So I'm going to type in y equals negative. Oh, be careful on the negative button, by the way. If you want a negative number, it's this little white button down here in the bottom. So this is for negative numbers, where this key is for subtraction. So watch out for that. Negative 1/2 x plus 3. So I can draw the graph. There it is. It's the same picture we got when we did it on the paper. And here's the nice thing. On the button that says graph, notice up in the blue it's got table. If you push second, table, the calculator builds a table for you. All right, so mine is starting at 0 and it's going 1, 2, 3, 4, 5, 6. I don't know if yours is doing that or not, but I can use the up and down arrow and change it, and I can get some negative numbers. So let's say I wanted to plug in all the numbers between negative 3 and 3. There they are. The calculator does it for me. So that makes it very quick and very easy to build your tables. You can use your calculator. Nothing's stopping you from doing that. Questions about that?